Hello students, myself Virendra Kumar Maurya, Associate Professor, Department of Electrical Engineering, School of Engineering, Babu Banarsi Das University, Lucknow. I welcome all of you in this video lecture. Please see this lecture thoroughly from beginning to end. I have covered so many important topics in this video. Now please see the board.
Students, here I am drawing a picture of single phase induction motor. This one is the rotor part. Rotor is the rotating part of the machine. It is placed in the slot of stator. Right? Rotor which is used over here is squirrel cage rotor. After that, now see the stator part of the machine. Stator part of the machine is the stationary part. There is a small gap in between rotor and inner periphery of stator. This gap is known as the air gap. There is a winding at the stator known as stator winding. It is single phase winding. Whole machine is clamped over the stand to provide it mechanical support. This is the portion in which we are marking as a dot is known as the rotor. Here the rotor is squirrel cage type rotor, right? Squirrel cage rotor. This one is the stator. There is a winding known as the stator winding, which is fed by the single phase supply. This one is single phase supply. Here stator winding is marked by the dots. This stator winding is also known as main winding. So this is about the single phase induction motor. As we know, single phase induction motor is not self-starting. What is the reason behind this? And how can we make single phase induction motor as self-starting? First of all, see the reason of its not self-starting. This one is the squirrel cage rotor, which is placed in between two poles. This one is the pole 1, this one is the pole 2. Although these are the electromagnetic poles, there is a flux in between this gap due to these poles. Right? Now the rotor is placed in the flux. A single phase induction motor is not self-starting but requires some starting means. The single phase stator winding produces a magnetic field that pulsates in strength in a sinusoidal manner. The field polarity reverses after each half cycle, but the field does not rotate. Consequently, the alternating flux cannot produce rotation in the stationary squirrel cage rotor. However, if the rotor of the single phase motor is rotated in one direction by some mechanical means, it will continue to run in the direction of rotation.
Now see the technology by which we are going to make it as a self-starting. These are the fluxes which is produced by the poles in between the gap, and rotor is placed in it. Now I am doing something new by which
these fluxes are shifted from one side to another. By the shifting of these fluxes from one side to another side, it becomes strengthened at one side and weakened at the other side. This action of shifting of flux is known as elastic action. This action is provided in the machine by splitting the poles. See the diagram very carefully. There are two poles, north and south. We are going to split it. Now one pole is divided in two parts and we put a copper ring at one side of the pole, and in the same way we put another copper ring on the one side of another pole, right, as shown in figure. These are known as the copper ring. So the pole which contains copper ring is known as shaded pole, and other part of the pole is known as unshaded pole. And in the gap there is a rotor known as squirrel cage rotor. Now see the pole very carefully. It has two parts. One is shaded pole, second one is unshaded pole. Now there is a binding over it known as main binding. Flux produced by unshaded pole is known as main flux, and flux produced by shaded pole, that is a pole containing copper ring, is known as shaded flux, right? That's why there are two fluxes. One is phi m, second one is phi s. When the main binding is energized with the supply, then these fluxes are produced, known as main flux and shaded flux, phi m and phi s. This one is the sinusoidal wave because sinusoidal source is connected across the main supply, that is alternating source. At point T1, current is increasing. It means that the induced EMF in the shaded pole produces flux phi s, which opposes to the main flux, that is phi m, according to the Lenz law. It means that strength of flux is high at the unshaded portion and low at the shaded portion, as shown in figure. For the point T2, the flux has reached almost maximum value and it is not changing. Consequently, the flux distribution across the pole is uniform, since no current is flowing through the shaded coil. It means that flux remains constant or uniform throughout the pole, as shown in figure. Now, at the point T3, as the flux decreases, current is induced in the shaded coil so as to oppose the decrease in current. Thus the flux in the shaded portion of the pole is strengthened, while that in the unshaded portion is weakened, as shown in figure. Now see the resultant flux and its shifting from unshaded pole to shaded pole. This is known as the elastic action. This shifting flux is like a rotating weak field moving in the direction from unshaded portion to the shaded portion of the pole. See the action? This one is rotor and split pole. Here main winding is wound over the pole, which is energized by the single phase supply. Once it is energized, phi m and phi s are developed. Consequently, phi r is developed, which give the rotational motion to the rotor. Now finally, see the single phase induction motor in overall. This one is the main winding which is energized by the single phase supply. That's why rotating field is developed over here, by which rotor is going to rotate in this gap. Although the single phase induction motor is not self-starting, but with the help of shaded pole we make it self-starting. Variation of torque with respect to the speed is known as torque speed characteristics. These are the two axes, one is for the speed, other for the torque. As soon as the starting torque starts to revolve the rotor, additional torque is produced by single phase induction motor action. The motor accelerates to a speed slightly below than the synchronous speed and runs as a single phase induction motor. It is clear from the characteristics that the starting torque of this motor is very low, the losses are high, and the power factor is low. As a result, the efficiency is low. For this reason, shaded pole motors are built only in small sizes of the power rating of order 40 watt or less. Advantages of single phase induction motor. It is cheap and simple in construction. Disadvantages: number 1, low power factor; number 2, low starting torque; number 3, low efficiency and high losses. Now applications. There are so many uses of single phase induction motor shaded pole type. 1. In toys. 2nd. In table fans, blowers, washing machine and refrigerator, etc. Some questions based on single phase induction motor shaded pole type. How can the rotation of a shaded pole motor be reversed? The rotation of the shaded pole motor can be reversed only if the machine is so constructed that the shading coil can be shifted to the other half of the pole. Otherwise, motor of this type cannot have their direction of rotation reversed. Now the next question: why are shaded pole motors very popular for low power applications? Saddle pole motors are very popular for low power application up to 40 watt due to the following reasons. Number 1, they have extremely simple construction.
There is no centrifugal switch. They are quite inexpensive and low maintenance. These are the reasons by which saddle pole motor is very popular for the low power applications.
So this is all about the single phase induction motor saddle pole type. Thank you.